So in the next two sections, we're going to focus on some pretty special types of sequences and series. One's called the arithmetic, that'll be the 12-2, and 12-3 is what they call the geometric. So I believe A is sequences, so just a list of them, and B is series, so the addition of them. And so an arithmetic sequence is a sequence that has a constant, which they label D. D they use because of difference, added to the first term to get the second term. So an arithmetic sequence has the same number being added every time. Now that can go down if that number is negative. If a negative 4 is being added every time, then we're going down in our sequence. If a 3 is being added every time, we're going up in our sequence, right? So whatever that common difference is, that's what they're referring to as D, the difference between the two. And so recursively, it's defined as, hey, here's the first term, and to get any other one, you're going to add this D. So a very standard way to approach the general nth term for this. So step one is to select any number to start with. You select a common difference and you can just build that sequence as you go. Now you're not going to be doing this selection because then there's going to be a million answers to the question that says build me an arithmetic sequence. But what you can see is that if you start at 5 and add 3 every time, then your sequence is 5, 8, plus 3 is 11, plus 3 is 14, plus 3 is 17, and so forth and so on, which is reflected down here at the bottom. So first of all, they're going to make sure that we can do what was back in A1, follow a recursive definition. And so you're starting in example 1 with 1, your common difference is 3. You're essentially just adding 3 every time. This is an arithmetic sequence. And you get 1, 4, 7, 10, 13, 17, 20, 23, 26, and it keeps going. In example 2, you're going to start out with 2, and you're going to add 5 every time. So you're going to get 2, 7, 12, 17, 22, 27, 32, so forth and so on. Nothing big there, so kind of nice. Common difference can be negative, like I mentioned. You're going to start at 7, and every time you're going to apply a difference of negative 4. So 7 minus 4 is 3, minus 4 is negative 1, minus 4 is negative 5, minus 4 is negative 9, minus 4 is negative 13, minus 4 is negative 17, and so forth and so on. And certainly it could be a fraction, right? There's nothing special about fractions. So if you thought that we were saying there was something where we said the indice, the n, could only be a positive number. That's the A1, the A2, the A3. We're not saying that those values can't be fractions, and they can, and here's an example. So we have a 3 halves, and every time we're going to add a half. So we get 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, and then naturally you would reduce those. So it's a little bit oh, he's saying it's common not to reduce so you can see the pattern. Okay, sounds good to me. So determining if a sequence is arithmetic or not. If something's arithmetic, you're looking for a common difference. So as you look from negative 3 to 1, you can see that there's an increase of 4. Is that same 4 increase every time? Yes. And so the common difference is 4. And so the sequence is arithmetic, with A1 being negative 3 and a common difference of 4. 5 minus 3 is 2. 2 minus 3 is negative 1. So this also has a common difference of negative 3. Here we have some odd numbers. Those all have a common difference of 2. No matter which ones you subtract, you get a nice 2 out of there. I'm not sure. Oh, careful. Not actually, that one right there is different. See, right? We got a 4 out of that. So it's not arithmetic because that 2 needs to be constant. What's being added here? Well, we're being added 2/3, 2/3, 2/3. So from everything we see, 2/3 is there. The dot 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 would mean that that same pattern continues. So interesting. A formula for finding the nth term of an arithmetic sequence is right here. It's the recursive definition, where you know an minus 1 plus d, right? And so we would find a formula for it. And so he's going to go through all of this, and so that's the recursive definition. So a1 plus 0d's, a1 plus d, and so you're trying to get something, right? a1 plus n1d, and so when you put it all together, n minus 1d, the nth term is found by adding one less than the number of the term to the first term. So the n general 1, so when we tried to start with an a1, is a1 plus n minus 1d. So that way when you plug in 1, you'll have a1 plus 1 minus 1d, and a1 would equal itself. So that's the best definition, I think. He gives a secondary one underneath, but that guy is the best and the most standard one that's there. If you wanted a2, look what a2 is. You know what a2 should be. Should be a1 plus d, and it is. And then a3 should be a1 plus a couple of d's, because it's two d's down the line. So if you take a look, relating everything back to a1, you can get an n general term for that that's not recursively defined. So if a1 equals 4 and d equals 5, then an is equal to 4 plus n minus 1 times 5. And if you need an n general 1, you would do the distribution and bring it together. And so you may have to do that in order to be successful in the exam or in the homework, right, to match what he has in the back of the book. Finding the first 5 terms of an arithmetic sequence as easy as plugging numbers in, right? Finding a specific term in a sequence. Yeah, this is great. So if we want to find the 11th term, no problem, just plug 11 in. You want to find the 16th term, just plug 16 in, and everything will work out great. Finding a specific term when an arithmetic sequence is expressed in linear form. So if we want to find the 16th term, you just plug 16 in. So you're learning that we just can plug in what we need. And then finding what term of arithmetic sequence we have would just be setting the 25 equal to that and solving for n and getting n equals 12. So the 12th term is negative 25. So it's very similar to the first section. They're just breaking it out where these are all very much the same. They are all arithmetic, a constant number being added in nature.